Hello and welcome to TidyX episode 152. TidyX is a screencast where we go through and explain how our code works. My name's Ellis Hughes, and as you can probably see, Patrick Ward is not able to be here today for the recording of episode 152. He's off actually giving a talk in Vegas right now. So really excited to be talking about this new project that we're starting. So we're going to be going through and teaching y'all how to make a data package. That was a question that somebody asked about, oh, how do I share data? What's a good way to be doing that? And so I built a number of data packages in a variety of jobs in the past. And so I think this is a really fantastic skill to understand. Also, it's a great introduction to just generally the concepts of building a package. So if you want to like and subscribe down below to make sure you get all the updates, we can get going on the first part of building a data package, which is, well, getting the data. So I'm going to make myself, let's not move that one. Let's move this, make my screen a little bit smaller here. And we're also going to do a bit of a bonus data viz at the very end to show you what the data, what we could potentially do with this data, and we're probably going to try to do that throughout the series. If you like that, leave a comment down below. All right, cool. So let's get going with this. So episode 152, data packaging, part one, Formula One data. First, we're gonna write the script that's going to be getting us the data. So we're going to call library tidyverse and library rvest. So tidyverse for all our wonderful data manipulation needs, and rvest for actually doing the web scraping. And so while I was looking for data to use for this series, I've been kind of getting into F1. I've been watching, Drive to Survive. It feels like that's very popular right now. So I thought that might be a good topic for us to use. So I went and found this website at racingstatistics.com. It's got a bunch of fantastic data kind of floating around there. When I was poking around with it a little bit more, I found they have this seasons tab here. And so they have historical data of F1 from 1950 all the way through to the current season. So that's really, really great for us to be able to um, access stuff. And then I took a look at the individual seasons. So I clicked at 1950 and a couple other ones. And this is kind of the general format. And so it's really good for us when we're doing our web scraping to see that the data are in a consistent format, or the website's in a consistent format, because that's going to make it easier for us to write the code that is going to be scraping that data, and we don't have to update the code for every single new year and write it manually. We can write it once and pull it all in. So let's take a quick look at what the code is doing. So if we want to be pulling in 1950, so we copy the URL here. So racingstatistics.com/en/seasons/1950. Pull that in using read HTML and assign that to X. So X now is a HTML document. So this is now reached out to their website and downloaded this content for us. And so now we can kind of poke around at it. Before I do that, let's actually do a right click. And so when you've got a website open, you can right click and then go into inspect. So when you click inspect, it brings up this handy dandy dev tools viewer. It oftentimes has the CSS shown as well. So the left-hand side, in this situation, we've got the HTML, which is all the code that's making up defining what the website layout will be and all the content of the layout will be, or the layout will be. And then the CSS is shown here on the right hand side. We're not going to worry ourselves with the CSS because that's not what we're caring about. What we want to know and understand is what is the high level structure of our website here. And specifically, these tables that we've got going on here, which is the championship standings, which is the 1950, it's done. I don't think they're going to be updating it. As well as the results per event. And then finally, there is a table, of course, showing comparison between teammates of the various constructors, but we're not particularly interested in that data set at this point in time. So let's bring up not this one, we want to look at the dev tools, which is this. And the nice thing about this is as we kind of mouse over the dev tools, it's going to highlight the content that we're actually looking at in in the website here. So let me kind of drag that over to the right. And so we can see, first, everything is contained within this layout div here. I don't know how clearly you can see that. And then within that, we've got more content that's stored within these other sub divs, right? So when we mouse over this div, this championship standings gets highlighted. When we mouse over this div, the results per event gets highlighted, and then we mouse over this last div, the teammate comparison shows up. So we know that we're going to want to be pulling all the elements with a class that is consistent across all of these. And so we can do a quick look, and they've got classes of blocks and blocks 2, blocks and blocks, blocks and blocks 1, blocks and blocks. So I think we're going to want to be pulling all the elements with class blocks. And so the way we go about doing that is we go back to our code and we write HTML nodes and say, I want all the contents with, or all the divs with the class blocks. And the way that you tell it you want the class is you do that dot there. And so now when it's going to be searching, we can pull this out, and we should expect 4 elements to be coming out there. And lo and behold, when we run that, we get 4. Next, we're going to call HTML table, which is going to pull out the table elements out of each one of those blocks and store it in a list. So now we can run that. And now we end up with year tables, and we have now a list of 4 entries. So there's 4 entries in this list. There's 4 tables technically, but that third entry did not have a table in it. So it's a table of size 0, or 0 rows and 0 columns. So we're going to now pull out the championship results, which is from that first entry in year tables, and we're going to call janitor clean names on this, because if we just open this up, we can see they've got the number sign here, the pound sign here, driver and driver listed twice, and we all know that Tidyverse tools do not like driver listed 3 times, constructor, and then the number of points they got. So we're going to call janitor on that. What janitor is going to do, it's going to clean up the names. And so it's going to be number, driver, driver 2, and driver 3. Now the reason we're getting those 3 drivers is, let's go quickly take a look back at the website here. And underneath this driver header here, we have 3 different columns. We have the flag representing the nationality of the driver, the name of the driver, and then the word season. And it's linked out now to the specific information for the driver for that season. But we don't really want that in our situation. So what we're going to do is we're going to select minus driver and driver 3. So that's going to remove the column of NAs, which is the column that is representing the flags, but it couldn't convert the flags into text. So that's why they're NAs. And then that driver 3 is just the word season, because that was the text that was in there. And finally, we're going to rename driver 2 to become driver, because that is the actual content that we care about from that table. And that's how we get championship results. Next, we're going to do the same sort of idea with the event table. So this is the table that shows the performance per event, so the race that they have. Again, we can see, let's call janitor clean names on this. Let's actually make this a little bit wider too. That winning driver is repeated twice. And that's, again, because, let's scroll down to the results per event. They, again, have winning driver spanning over the flag or the nationality of the driver, as well as the driver name. Again, we can't really do much with this text here. It's not preserving it for us. So what we're going to want to do is we're going to want to remove that column of NAs, because it couldn't convert it into anything for us. And then we're going to, again, rename winning driver into driver, just so that we're consistent between our championship results and event results. So now we end up with a table that looks like this. And that's fantastic. But, we've now only done that for 1950. And we want all of the years of F1 racing, right? We don't want to just constrain ourselves to, the 1950s where there were only 7 races. So we want to be pulling this for all of the years of F1. And so the nice thing about the way that they've laid out their website is the URL is actually very consistent for us, and it's probably easier for the devs at racingstatistics.com to be able to have the structure where you can see it's racingstatistics.com/en indicating English, seasons, and then 1950. If you go to 1960, it's the same structure of URL, except the last thing is updated to be 1960, which means for us, we can go through and just update this last piece of the URL whenever we want to be pulling the next year. And so we're going to do that exactly. So we're going to create a new function called F1 season records. It's going to take a single argument called year. It's going to construct the URL. We're going to use the function file.path, which conveniently puts a slash between seasons and year. You could do paste 0, but I prefer this structure. And then we're going to paste in the year. We're going to read the HTML and then do the exact same code that we just talked about explaining how that worked, because the structure of the HTML is identical across all of these years. And then we're going to construct a list. And this list is going to contain what year this data is pulled for, the championship results, as well as the event results. So we're going to construct that function, and now all we need to do in order to pull from 1950 all the way to 2020, and we could even pull this latest year as well if we wanted to, but I chose to stop at 2020, is to create a vector from 1950 to 2020 and use map. So map is from per, and it's going to apply every single year to this function and store the results in a list. And so I'm not going to run that now, I've actually pre-run this, because this takes several minutes to run, because even though it only takes a fraction of a second for us to do this, just the web scraping can take a minute. So now we've got this list that is now flashing in front of us, and it's going to have 71 elements, because 1950 through 2020, that's 71 entries. And we have the year, we have the championship results, as well as the event results. And this is for 2020. Then in the 70th entry, we have event results, we have championship results, and the year for 2019. And so we can kind of go back and we have all this historical data now. And that's going to be super great for us to be able to kind of go through and dive in. And we could also change the format of this, because right now it's a long list. We could actually just stack all of the event results, and we could just stack all of the championship results and add a column to both of them indicating the year that's from. And then we would have data sets of F1 historical championship results and F1 historical event results, all stored very nicely in 2 data frames. And that's the data that we will be using in our F1 data package. So now we have the data, now we can kind of construct with it. So now we're going to jump into what could you do with this data. And one thing that I think would be fun to do would be who was the winning constructor for every year between 1950 and 2020. And let's create a waffle plot to do this and to visualize this nicely. So we're going to call library ggplot2, and this will make it so we can use ggplot2 and the cool, or the great data viz library and visualization tools. We're going to take historical F1 data, and now for every entry in this list, we're going to pull out the championship results. We're going to group by constructor and figure out which of the constructors had the most points, which is based on which driver got the most points for each constructor, and add them together. So we can, because we have all of the records for all of the drivers for every year, we can just go, okay, these 3 drivers raced for Alfa Romeo, or Maserati or Ferrari or whatever team, and we're going to now add those points together, and those are the points for the constructor. We're then going to arrange that data set, which is now only constructor and number of points they got that year, in descending order, so the team with the most points is listed at the top. We're going to slice the first one, so we only get the winning constructor, and we're going to add in the column for year into this data set. And so we're going to use map to do that. We're going to bind all the rows together, and then we're going to arrange by year to make sure that it is in the correct order. So we're going to call that, It takes just a second to run, and we end up with this now. So we have Alfa Romeo won with 88 points in 1950. And Alfa Romeo won again with 71 points in 51. Ferrari came in the next 2 years after that, then Maserati, then Mercedes, then Ferrari. So it's kind of fun to see, or to me, interesting to see brands that aren't like Alfa Romeo. I know the brand, but I don't think that they're racing anymore. Or even in 1959, Cooper Climax. I don't think they're still around. So that's kind of fun to see some history in F1. So now we're gonna make our actual plot. We're gonna use theme set to set the theme to be void, which means that there's no elements that exist on the plot because I want it to be blank. I only want it to be the tiles because we're going to be making a waffle plot. So we're going to call that. Now the number of columns I would like to have our waffle plot have is 10. That way we have one for every year from 1950 to 59, and then the next year goes down to 1960. That's a whole row, then 70, then 80, then 90s, then 2000s, and so on. So we're going to set end call to be 10. Now we're going to actually, we have to construct our waffle plot. And so we're going to take the constructors. We're going to, again, ensure that it's arranged by year. And we're going to create two new columns in this data set, column index and row index. And so this is what's going to be telling ggplot2 where to place the tile that we're going to be constructing. And so we're going to use some fun techniques here. So we're going to use row number, which is going to be what row number is 1 through n being the number of rows in constructors. We're going to subtract 1, and we're going to get the modulo of n call. What the modulo does is basically the remainder when you divide a value. So if you do 5 modulo 2, this is going to give us 1 because 5 can get divided into 2 twice evenly, and so that gives us 4. And the remainder of 4 and 5 is 1. Or in 1 or 1 and 2 is 1. So then, the same sort of logic holds. So then when we do 1 modulo 10, that's going to return 1. When we do 11 modulo 10, that's going to also return 1 because it's 1 can't be the remainder of the value divided by 10 is 1. And we're going to do a similar sort of idea here for row index, but in this case, we're going to do row number and subtract 1 and divide by n call, and then take the floor of that. And so that's going to smush everything down. So if it's 1 through 10, this is going to be a value of, and it will actually be the first ones because I'm subtracting 1 would be 0 through 9. Let me actually zoom in a little bit. I'm realizing this is a little small. 0 through 9 divided by 10, of course, gives us 0 to 0.9. But when I take the floor of that, that's going to smoosh them all down to 0. Right, and then I'm going to do a negative. So now when we have the values 10 through 19, this gives us 1s, but I want to stack vertically where 1950 is at the very top, and then it's all progressing down. And so that's why we have the negative row index here. We're going to do ggplot. We're going to set the aesthetics to be x is the col index and y is the row index. We're going to do geom tile, which is going to give us rectangles, and we're going to set the fill of those rectangles to be the constructor. We're going to add a geom text on top of that tile so you can see the year that it is. And then we're going to set the scale of the fill. So by default, it's going to be filling those tiles using the rainbow theme, which is not what we'd like to do. What I would like to do is, because I have the names of the teams, I would like to be coloring those tiles by the best representative livery of the team. So the livery is how the cars are painted, basically. And so what I did is I could have gone and went to Wikipedia or anywhere else online and asked, okay, Alfa Romeo, what is a good hex color? Or what is Alfa Romeo's hex color? Or what is Braun's hex color? Or what is Lotus Climax's hex color? But instead what I did is I just reached out to ChatGPT, said, hey, given this vector of F1 teams, what would be a best representative hex code for the livery of these teams? And so it gave me these hex codes. So I don't take responsibility for how accurate they are. And then, of course, you add the labels. So you add title, which is the Eras of Dominance, and the subtitle being F1 Constructors Championships from 1950 to 2020. And now when we run this, we get the same plot that I showed you at the very beginning here, where we have the years printed above the tiles. The tiles are now colored for the average livery of the various teams. So let's actually now zoom out so that we can see. It's not letting me zoom out. There we go. It's just taking a moment. We can see that Alfa Romeo won the first two, then it was Ferrari, then it was Maserati, then it was Mercedes. And so you can kind of see some of the patterns here. Then there's very clear eras of dominance, where like here is Mercedes winning from 2014 through 2020. And then we have Red Bull winning from 2010 to 2013. So it's kind of fun to see some historical, or like McLaren, 1984, 85, 88, 89 through 91, 98 and 99. So it's kind of fun to see this plot and some history in F1. Uh, just I don't know. I just think it's interesting. So with that, we're going to end episode 152 of TidyX. Thank you for joining us for this episode. If the work that we have done has positively impacted you, we do have a Patreon page if you wouldn't mind joining that. If not, liking and subscribing, it lets us know that we're on the right track, that we're doing things that you're enjoying. And then if you'd like to reach out and contact and chat with us, leave a comment down below or send us an email at tidy.explained@gmail.com. Thank you so much, and keep on exploring your world.